Hello friends, in previous lecture we discussed the electrophilic substitution reactions of aromatic hydrocarbon, in which we discussed the halogenation, sulfonation and nitration reaction. Today we will start the remaining part of aromatic hydrocarbon, in which number 1, the Friedel reaction. The Friedel reaction, it having two types: FC alkylation, that means Friedel alkylation reactions, and FC acylation, that means the Friedel acylation reaction. First, we discuss the Friedel alkylation. Friends, the Friedel reaction is an electrophilic substitution reaction in which the alkyl group is introduced in the benzene ring. That means we have to keep in mind the Friedel reaction is the electrophilic substitution reaction. Electrophilic substitution reaction, and here alkyl group is introduced in the benzene ring. When we consider the Friedel alkylation, here the benzene is reacted with alkyl halide. Benzene is reacted with alkyl halide in the presence of Lewis acid, and the Lewis acid, it may be the AlX3, that means it may be the AlCl3, and in this reaction this Lewis acid is used as a catalyst. That means in Friedel alkylation reaction, benzene on treatment with the alkyl halide Rx, that means alkyl halide, and here one of the hydrogen of the benzene ring is replaced by the alkyl halide here. That means here hydrogen is replaced by the R plus byproduct is HX, and the final product is alkyl benzene. That means here R group is introduced in the benzene ring. It's called as Friedel alkylation reaction. This is a general reaction. If we take one example, benzene plus methyl chloride in presence of Lewis acid AlCl3, and we know that the Lewis acid here, it acts as a catalyst, and here we get the methyl benzene plus AlCl3 plus HCl. That means here one of the hydrogen atom of the hydrogen here replaced by the alkyl halide, that means CH. That means here H is replaced by the CH3. That means here we get the methyl benzene. If you go in detail the mechanism of the Friedel alkylation reaction, that means it is substitution reaction. Here benzene plus CH3Cl AlCl3. AlCl3, it is the Lewis acid. Here introduce this methyl group plus HCl. The Friedel alkylation reactions it occurs in 3 steps. Number 1, the first step is there is the generation of electrophile. That means the generation of electrophile, that is the methyl carbonium ion. That means here CH3Cl, that means this is alkyl halide plus AlCl3. That means there is first reaction between the alkyl halide and the AlCl3. That means here CH3 plus, that means there is formation of the methyl carbonium, and this is nothing but this methyl carbonium, it is nothing but the electrophile plus AlCl4. That means this is the first step, there is generation of electrophile. Now in second step, there is attack of electrophile to benzene ring and form sigma complex, which is stabilized by resonance. That means in next step, that means this benzene is attack on this methyl carbonium, and there is formation of a sigma complex, and this sigma complex is stabilized by the resonance by these two double bond. That means these two double bond is stabilized by this carbocation. That means we can write the resonating structure. Okay, now in step number 3, there is abstraction of H plus from sigma complex to form electrophilic substitution product. That means here the AlCl4 minus, it will abstract this proton, and here minus H plus we get the methyl benzene plus HCl plus AlCl3. Okay, that means next step is, it is also called as the minus H plus or the aromatization. We get again maintain the aromatic character of the benzene ring. That means I repeat it, the Friedel alkylation reaction, it having 3 steps. First step is the generation of electrophile. Second step is attack of electrophile to benzene ring, and there is formation of the sigma complex. Now then step third, abstraction of H plus from the sigma complex. This is about the Friedel-Crafts alkylation reaction. Okay. Now Friedel-Crafts acylation reaction. What about the Friedel-Crafts acylation reaction? In Friedel-Crafts acylation, again it is the electrophilic substitution reaction in which acyl group is introduced in the aromatic ring. It is similar to the Friedel-Crafts alkylation reaction. The effective electrophile is acylation, is acylium ion. That means in Friedel-Crafts acylation reaction, the most important electrophile is acylium cation. Acylium ion or acylium, we can it called acylium cation, acylium ion, and it can be generated by using following methods. We discuss one by one. Here, this is the general mechanism of the Friedel-Crafts acylation. How will you generate the acylium ion from the various methods, or from the various or the different types of the compounds? We can say we use different types of the compounds. Number one, acid chloride. Acid chlorides plus AlCl3. Acid chlorides in presence of Lewis acid AlCl3, and we know the mechanism. There is formation of the complex between this acyl chloride and this Lewis acid, and here the Cl will be depart. That means there is formation of the complex between the Cl and AlCl3. Then this will be depart, and here we get the RC double bond O plus, that means the acylium ion plus AlCl4. Now the next method, the generation of acylium ion from the anhydride, R C double bond O, C double bond OR plus in presence of Lewis acid AlCl3, and here this there is cleavage of here, this will be cleave, and we get the R C double bond O plus, that means this acylium ion plus the byproduct R C double bond O AlCl3 minus. Next step, from the acid on treatment with H2SO4, here protonation will be take place and removal of water molecule. Here we get the acylium ion R C double bond O plus, and in next step, take example here, benzene plus acid chloride. Acid chlorides in presence of the Lewis acid AlCl3. Here the hydrogen replaced by these acid chlorides, and here we get the acylium ion plus AlCl3 plus SCl. That means substitution reaction. That means this benzene containing this double bond, it will be attack on this C double bond O, and there is a departure of this chlorine, and here we get the benzene containing C double bond OR. That means the substituted products, benzene containing, or there is introduction of the, or the introduce the acyl ion plus AlCl3 plus SCl. And there are some important features of the Friedel-Crafts reaction. The most important features of the Friedel-Crafts reaction: number one, in Friedel-Crafts alkylation, the alkyl group is introduced in the benzene ring, and it activates the benzene ring. That means when we perform the Friedel-Crafts alkylation reaction, at that time it activates the benzene ring, and due to this it activates the benzene ring. Due to this, there is polyalkylation take place in Friedel-Crafts alkylation. That means this is actual drawback of the Friedel-Crafts alkylation reaction. But in case of Friedel-Crafts acylation reaction, the acyl group is introduced in the benzene ring. When acyl group is introduced in the benzene ring, at that time it deactivates the benzene ring. That means there is no possibility of the polyalkylated product is formed. Like Friedel-Crafts alkylation reaction, there is no possibility of rearrangement, and that means in case of Friedel-Crafts alkylation reaction, there is no possibility of rearrangement. The first and second is the most important. That means in Friedel-Crafts alkylation, there is possibility of the polyalkylated product, but in case of the Friedel-Crafts acylation, there is no possibility of the formation of the polyalkylated product. In an exam, the question asks why in Friedel-Crafts alkylation there is polyalkylated product is formed, but in case of Friedel-Crafts acylation there is no polyalkylated product. The answer is simple. In case of Friedel-Crafts alkylation, if alkyl group is introduced in the benzene ring, at that time it activates the benzene ring, Due to this, polyalkylation takes place. But in case of the Friedel-Crafts acylation reaction, the acyl group is introduced in the benzene ring. It deactivates the benzene ring. Therefore, there is no possibility of the polyalkylated product is formed. Okay, thank you.